Hello, so it has been a long time since the last video I made. So I would try to pick up from where I have left the last time. So I would be starting with the LAMMPS tutorial and the second last part, which is defining groups. So if I look at the code section, here you can see that different groups and regions have been defined. So all this might be a bit confusing for you right now, but I can say that after you are done with the video, you can understand every single line that has been written here. So at first we need to understand what is region. So in LAMMPS, the region command is a command which defines the geometric regions in a simulation space. So you define a region in the geometric space which may or may not contain atoms. So you define this by specifying the coordinates mainly. So when you are defining the region, if you look at the code, region ID. So first of all, you assign a ID to every region you define. Then you define the style of the region. For example, your region can be of a cone shape or a cylindrical shape or the shape of a box. So you need to define what kind of region, you need to write what kind of region you are defining. So if you look at the examples, you can see that there are different kinds of regions here, like for the block. So after you have defined your region or what kind of region you are defining, you need to put in some arguments. For example, when you are defining a block, you need to put in the coordinates. For example, let this be a block. So in order to define this region, you need to define the coordinates. Like your block can be 3 units along the x-axis, 3 units along the y-axis, and 2 units along the z-axis. So all these units you need to mention in your region command. Like if you see at the first example, region 1. So your ID number is 1, the type of region is block, and -3 to 5 indicates that it is from the -3 to +5 in the x-axis, from infinity to 10 in the y-axis, and the z-axis is not defined, so it will be the whole region along the z-axis. So in this way you can define if it's a sphere or a cylinder, etc. Sometimes your region may be open, and you can also perform different kinds of interactions within the region, and moreover your region may be dynamic. So I will explain about the dynamic portion when I go to the group part. So I have already explained different kinds of ID, style, arguments, keyword, common and special use. So in case of common use, you are using it to define a particular area. This is the common use. Or you can also move or rotate your region during a simulation. So this is the common use. What are the special considerations? Like you can add or subtract two regions. For example, you can define a region here, you can define a region here, then you can add these two regions to get a new region. So in this way you can use intersection or union to add two regions. And now I will be going to the group. So so what is group? The group command in LAMMPS is used to define a collection of atoms, allowing you to perform operations on them as a single unit. So you are defining a particular group of atoms in a particular group, so that when you are performing any operations, it operates on the whole group as a single unit. So the difference between region and groups is in case of region, you are defining a specific area within a geometric configuration. In case of groups, you are assigning a group number or ID to a group of atoms. So these two are different in this sense. So if you look at the command group ID style arguments, so at first the ID, it defines what is the number or the ID you are assigning to the group. The style defines what kind of what kind of operation or what you are going to do with that group. For example, there are different kinds of style, or I will go when I go to the example part you will understand. And there are also arguments. For example, you can delete the group, you can add the group, you can do a lot of things. So let me go into some examples. Like, you can group based on the region. For example, all the atoms on this portion of the region, you can assign them to one group. For example, you have region 1, you have region 2. So now you can say that all the atoms within these two regions are a single group which you have assigned under the name 1. So in this way you can assign groups based on regions. You can also assign groups based on type. For example, here you can see group water type 3,4, which means that all the atoms which belongs to the type 3 and 4 of water are under this group. Next, you can also group atoms based on their identity. You can group atoms based on their molecules. Like here you can see poly A molecule. So what kind of molecule they are forming, you can also assign groups based on that. You can add or subtract groups. For example, here you can see that boundary subtract union lower upper, which means that you are adding the groups of the lower and the upper region. So in this way you can add or subtract groups, and also you can make the group dynamic. So dynamic means that when you are running the simulations, the group of atoms will change. For example, this is your region, here are 6 atoms, but after the simulation is running, these atoms might leave the group. So your new group will not be the 6 atoms but the 4 atoms present here. So in this way you are making the definition of a group dynamic, which means it will not be fixed throughout the simulation. And you can change this group. This group will be assigned by a new identity every 100 simulation steps. In this way you can make your group dynamic. And finally we will go over the set command. So what is set? So here you can see the set command in LAMMPS is used to modify properties of atoms, molecules, or group of atoms. So in this command you are mainly assigning the property of the groups or atoms which you have already selected. For example, if you look at the examples here, you can see that set type to charge 1. So you are changing all wait, let me go through a particular example like this one. Set type H charge 0.5. So all the atoms within the type H, which might be hydrogen, you are setting all of their charges to 0.5. In this way you can set their types, you can set their velocities, you can set their charges. In this way you can set the properties of particular atoms which are assigned under any particular group or region. You are setting their properties. So now I will break down the code so you can understand what is going on in that .in file. Now if I define the axis here, this is my x-axis, this is my y-axis, and the perpendicular here is my z-axis. So if you see these two region commands, at first there is a 1 and 2, which means that we are assigning the ID 1 and 2. Then you can see block. Block means our region is of the category block. Infinite to infinite, which means along the x-axis I am not putting any boundaries. Along the y-axis I am putting boundaries infinite to 0.25, which means if I explain here, this is infinite and this is 0.25. So this is my geometric configuration of the lower region, because I have no restrictions on the z-axis. So if you look at the region 2, here you can see that I have no restrictions on the x and the z-axis, but I have restrictions on the y-axis. Here you can see from 38.75 to infinity. This point is 38.75 and this point is infinity, which means you are assigning this whole part to the upper region. So now you have defined two regions. This is the upper, which is the block region 2. This is the lower, which is the region 1. Now what you will do, I have defined the regions. Now for these two, look here, region left upper block. So this left upper block along the x-axis, I am going from infinity to 20. Infinity means 0 and 20 means this. So this region I am now defining infinity to 20. Then along the y-axis, now if you look at the y-axis, 20 to infinity, which means this point is 20, and here I am setting no restrictions, and this block I have already defined as left upper. This block I have defined as left upper. In the similar way, you will see that from 0 to 20, this is my left lower. So I have defined 1 2 3 4 regions. Now I have defined them as geometrical configurations. Now I will have to assign the atoms within these regions to particular groups. So at first you can see that group lower region 1. That means all the atoms present within the lower region, I am defining them as 1. This is 1. I am defining them as a group. I am defining all of them as a group. Okay. Now if you look at the second one here, group upper region 2. So all the atoms present within the upper region has been defined under the group upper. Next, what I am doing is I am adding these two regions. Here you can see the command union, which means I am adding all the atoms within these two group, and then I am saying group mobile subtract all boundary. After adding these two, I am naming it boundary. Then what I am doing is group mobile subtract all boundary. What this means is I am setting all the atoms except the boundary atoms as mobile. That means all of the atoms here, all of them are mobile except the green and the pink strip of atoms present here. Next you can see that I am defining the atoms here as group. I am defining the atoms here as group, and then the rest of the code is very easy. Group left upper type 2, group left lower type 3, group lower type 4, group upper type 5. So I am assigning all of them as types, but the main thing you have to notice is I am setting the green and the pink as static and all the atoms without these two groups as mobile, which means after the simulation is run, these two group of atoms will not change their configuration, and all the other atoms will change their configuration or the way they are interacting with each other. So this is the main takeover, and I hope you can now understand how to define groups, regions, and assign particular properties to them. This is all.